Greetings. Now we are going to explore about series. So series is a sum of terms in a sequence, and the order of terms matter when evolving the formula. And series is used in mathematical analysis, numerical computing, and calculus intermediate, in which you will find in complex numbers. And if you look at the bottom, you see the series for sine and cosine, and which I'm going to explain about Maclaurin series later. Now, the reason I'm going to teach series is mainly because first, it's somewhat tedious, and you need to find out how it works. The second, I personally think, is such an underrated topic, as people somewhat like feel bored when they learn this topic. Third is that it's a continuation of the progression topic, which is why I'm going to teach this topic, series. Now, here comes the sum of natural numbers, and there are three formulas that you see. So, sum of natural numbers is a short formula of the sum of numbers from 1 to a finite value, in which the first term is 1, the common difference is also 1, and that is for the first one. For the linear one, which is R itself, you can use the Gauss method as I've explained in the progressions video. The second and third one, the square and cube, you need, for squared, you need n cube minus n minus 1 cube. As for the cube series, is n power 4 minus n minus 1 power 4. Okay, this one is, I put it because I found it on a website called Geeks for Geeks, and they show how to derive the formula. Unfortunately, I don't have a explanation as to why you need to use the method. I have like no clue. I don't have like a true rationale as to why you use them. You can just find out how these formulas are derived. Now, let us look into the Taylor series. So, Taylor series is an infinite sum representing a smooth function. It is calculated using a function's derivative at a single point. And to get the Taylor series, you can do this using power series, and then you differentiate. That is how the Taylor series is formed. And Taylor series uses a constant, which is in this case A, and if you make that constant to become something, then you can incorporate into the Taylor series formula. You can use this Taylor series to derive any function. However, the problem here is that Taylor series is more complex due to the use of constant. I will introduce to you Maclaurin series, which is much simpler, though is similar to Taylor series. Now we are into the Maclaurin series formula. If you look at the top, you can clearly see Maclaurin series is much simpler than the Taylor's. So it is similar to the Taylor's, which is true. However, A is 0, which means that the Maclaurin series is used at the origin, such that A is 0. And if you look at the right, you can see how Maclaurin series of exponential function e to the x looks like. You can see the series like that. You can use this Maclaurin series to formulate for sine, cosine, arctangent, ln 1 minus x, and a lot of formulas you can derive. Just make sure that you do the several differentiation to different orders, and then you find the constants for each and every derivative, and then you make the the series yourself. And I believe that's it for me. I hope you like this video. Thank you.